right. I think in the interest of time, I'm going to start this. So welcome to OA Week 2025, day one. Very exciting start. My name is Katarina Scholl, and I'm an Associate Project Officer for Ocean Acidification at the ISC of UNESCO. I'm also part of the GOA-ON Secretariat. Please note that this session is being recorded. So OA Week is presented by 4 sponsoring organizations. First, we have GOA-ON, the Global Ocean Acidification Observing Network. Second, NOAA, the United States National Oceanic and Atmospheric Administration. Third, the IAEA-OA ICC, the International Atomic Energy Agency Ocean Acidification International Coordination Center. And last but not least, the IOC, the Intergovernmental Oceanographic Commission of the United Nations Educational, Scientific, and Cultural Organization, UNESCO. A bit of background here. GOA-ON was established in 2012 with just a handful of members, and since then has grown immensely. It now has over 1,200 members from over 110 countries and consists also of 11 regional hubs, like the Northeast Atlantic Hub, which span across continents and oceanographic regions. We'll be hearing from most of them throughout OA Week. And if you're not a member yet, please join us today by visiting goaon.org. OA Week was established in 2020 and returned in 2021 when events and conferences were postponed due to the COVID pandemic. Following the successful in-person symposium of the 5th Ocean and High CO2 World Symposium in 2022, OA Week has become an annual event to maintain the momentum around OA research and provide a virtual platform for the ocean acidification community to exchange their latest findings. We're thrilled, as ever, to have a wide range of ocean acidification topics and speakers from around the world. I'd like to have a few words on housekeeping before we get really started. So during the presentation, all participants are in listen-only mode. You're welcome to type any questions into the Q&A box, which should be at the bottom of your screen, and we can then answer them after each of the presentations. You can also use the raise your hand function in the toolbox, and we can call on you to ask your questions directly. And with this, I would like to hand over to our moderator for the session, Jos Gilder from the Netherlands, Rijkswaterstaat. Jos is co-chair of OSPAR's working group on a changing ocean climate and ocean acidification. Most of his work, besides this group, involves international collaboration at the science policy interface, most notably concerning the EU Marine Strategy Framework Directive. And he's also active in OSPAR's Biodiversity Committee, the EU Common Implementation Strategy for the Marine Strategy Framework Directive, and is the national representative for the Netherlands and IC's Science Committee. He's also national delegate on the IC's Council. And with that, Jos, I will hand over to you. The floor is yours.
Thank you very much. I'll try to share my screen. Is that working?
That looks great.
All right, so thank you very much and welcome everyone to this Northeast Atlantic Hub session, which we do together with the Northeast Atlantic Hub and the OSPAR working group on a changing ocean climate and ocean acidification. We'll be presenting this seminar with 3 people, one of them being me, and the others, Helen Findlay and Yuri Artioli, I will introduce later on. Just a little outline. We'll start with a little introduction by me, mostly about what OSPAR is and what OSPAR does. Then Helen will have a short presentation on time series and an ocean acidification indicator. Yuri will tell us something about our work on future projections. And then I will have a short presentation on indicators of biological impact. And we aim to have, let's say, a general discussion and questions at the end of the session. But if there's targeted, really detailed questions about one of the sub-presentations, we can take those after the presentations themselves. So OSPAR is the Regional Sea Convention for the protection of the Northeast Atlantic environment. You see here in the picture the geographical area that it covers, and in green the countries that are contracting party to OSPAR. So there's 15 governments, and the EU is also a contracting party. And I think an interesting thing to notice here is that the OSPAR area is subdivided into 5 regions, as we call them. So we have the Arctic region in the north, the Greater North Sea, the Celtic Seas, the Bay of Biscay and Iberian coast, and the wider Atlantic. So OSPAR's vision is a vision of a clean, healthy, and biologically diverse Northeast Atlantic Ocean, which is productive, used sustainably, and resilient to climate change and ocean acidification. And I guess everyone can subscribe to that vision. So OSPAR has their so-called Northeast Atlantic Environment Strategy, which is updated every 10 years. So the current one runs until 2030. And in this strategy, we have 12 high-level strategic objectives, and 3 of them are directly related to climate change and ocean acidification. So there's objective number 10, which is about raising awareness of climate change and ocean acidification by monitoring, analyzing, and communicating their effects. This is where the core of our group's work is sitting at. The others are about facilitating the adaptation to the impacts of climate change and ocean acidification. And the last one is about mitigating climate change and ocean acidification by contributing to global efforts, as it says here. But of course, there's only a limited thing that OSPAR itself can do. But of course, we can help work on measures that have to do with nature restoration, for example, to improve the role or the function of the oceans in mitigating climate change. So the working group GOA-ON, which is the working group on changing ocean climate and ocean acidification, consists of roughly 30 members from 12 countries, and we have, let's say, 4 subgroups active in that working group. And the stuff that we try to do is amongst other things, the coordination of monitoring programs, maintaining a network and dialogue with the wider expert community, and I guess that's one of the things that we're doing today, to facilitate the dialogue between policymakers and experts, both within and outside of OSPAR, to advance the dialogue on adaptation to and mitigation of climate change and ocean acidification impacts, inventorying the evidence that we have for the impact of climate change and ocean acidification, feed into discussions on ecosystem resilience, which are quite prevalent in OSPAR at the moment. Not unimportantly, the delivery of the OSPAR climate change and ocean acidification state assessments, and the incorporation of future projection products in OSPAR assessments. So not just in the climate change and ocean acidification assessments, but also in others. So OSPAR has delivered their quality status report in 2023, which included a so-called climate change thematic assessment and an ocean acidification assessment. You can look those up at the OSPAR website. And today we'll tell also a little bit about the contents of that ocean acidification assessment. And the next time around will be in 2029, when we aim to publish a combined climate change and ocean acidification assessment. And that means that if it's to be published in 29, we'll start analyzing, writing, and producing pretty much now. So this is we're at the starting phase of producing that. So that's the let's say the introduction on OSPAR and what OSPAR is and does, which I kept as brief as I could. And we're moving to the topic of time series and an ocean acidification indicator. This will be presented by Helen Finlay. And Helen is an expert member of OSPAR's working group GOA-ON. She also chairs the Northeast Atlantic Ocean Acidification Hub of GOA-ON, and is co-lead for the UN Ocean Decade Program, Ocean Acidification Research for Sustainability, the ORS program. She was co-lead for the physical chemistry chapter of the QSR in 2023, and manages the PML carbonate chemistry time series and conducts laboratory and field work to investigate the impacts of changing ocean chemistry on marine ecosystems. Helen, are you ready?
I think so. Can you hear me okay?
Yep.
Great. So we're just going to carry on with this slideshow and I'll just say next slide, yeah. So thank you, Jos, thanks for the introduction. So as Jos mentioned, I was brought in as an expert member when the first assessment was being undertaken through primarily actually to represent the Northeast Atlantic Hub and GOA-ON in OSPAR. Well, that was part of the reason, but also as an expert in member of time series analysis and looking at environmental impacts. And so why are we interested in OA indicators and time series, or which ones do we think about using? We had quite a lot of discussion actually initially to kind of think about what indicators should we use, and looking at the data that we had available in the inventory and elsewhere, and thinking about what was most accessible, we decided that pH was probably the best indicator that we had available at the time. It's most commonly measured, and you can see the pie chart there represents actually an assessment of the inventory that we have that shows actually 30% of the monitoring that takes place in the Northeast Atlantic that is fed into OSPAR is measures of pH only, and the remaining there you can see there's different amounts of people monitoring different parameters of the carbonate system, but primarily actually pH is the most abundant of those measures. pH is also biologically relevant. There's good reason to include it as a biologically relevant indicator. And it's translatable into policy language. We obviously get a lot of people that don't understand pH, and it's like all of the carbonate chemistry, which one is the easiest to actually translate is a big discussion question. But actually, pH is understandable, I think, when you explain it correctly. Aragonite saturation state is also commonly used elsewhere, and so recognizing that it kind of adds another perspective, especially in terms of thinking about dissolution and its relationship to calcium carbonate minerals. Then we also, where available, decided to use aragonite saturation state as a common indicator. That also recognizes that some of the pH data that we have historically isn't necessarily the high quality that we have come to expect from the climate ocean acidification community. And so there's the best data that we have actually is data sets that we get from ocean monitoring that's been carried out specifically for ocean acidification research that has more than one parameter available that allows us to check that historic pH. What do we do with those indicators? Well, we use them primarily for updating the status of OA in the OSPAR regions, and we'll talk about the QSR in a minute, but also thinking about evaluating the potential risk of impact on species. Next slide, please, Jos. So this is just to summarize that first chapter of the ocean acidification assessment that we wrote for the Quality Status Report 2023. And the headline really is that line at the top there, that ocean acidification was observed in all OSPAR regions, but the rate varied. And what we did for this assessment was used 4 approaches or tools, which I'll briefly go through here. The first was actually to look at time series stations. So we had 26 long-term stations with 20 of which had data for more than 10 years. Iceland and Norway had the 2 longest, most complete carbon system time series, and they're primarily offshore, as you can see on this rather small map, but they're the grey ones, OWS, M, LN6 and FX9 around Iceland and the Norwegian Sea. And then the remaining stations were clustered around the southern North Sea, into the English Channel and down into the Bay of Biscay along the French coast. So the rest were mostly coastal, very near shore. They rarely had full carbonate system. They were primarily pH data. Some of them did have the other carbonate system as well, but there was also some data where we are still having to sort of tie up the older data compared to newer data uncertainties. And so the quality of some of those older data is questionable, and we made sure to kind of discuss the quality at the end in the annex of that report. So you can see there just how variable those trends are. So the offshore trends are generally faster than the global average, but within kind of a reasonable amount of that. And then as you move from the North Sea in those red bars there, throughout down into the Western English Channel in the blue bars, and then into the Bay of Biscay in the purple bars there, you can see that the rate of acidification has almost an order of magnitude greater in those time series. Next slide, please, yes. So the second approach we used was to use reconstruction time series, so synthesis products. And we used the Ocean Soda ETHZ product, and the CMEMS product there. So there's the two figures on the right, the middle and the right is Ocean Soda and CMEMS. And then we also looked at Hindcast product from the NEMO-ERSIM model for just the kind of Northwest European shelf region, as you can see there on the left panel. And we looked at both trends in pH and aragonite saturation state for those, and those are what those maps show there. Obviously, those products are lower resolution, so trying to match those to single point stations was one of the tricky things that we looked at but didn't really emphasize too much, because they are kind of measuring different things. But actually this gives us that spatial resolution that those time series weren't able to give us, and look at kind of much more broader across, especially across the sort of Arctic and Atlantic region that we didn't really get covered by those time series stations. Next slide, please. The final approach was to look more at the ocean interior. So we used GLODAP to do this. And again, it's kind of picking out stations that were available that had some sort of longevity to them that allowed us to kind of look through time to see how those trends in pH and aragonite saturation state were changing through the water column. And you can see examples here of 5 different locations in different regions of the North Sea, the Greater North Atlantic region there. Next slide, please. So what are our next steps looking forward to the 2029 assessment? Well, we're currently kind of updating the monitoring guidelines, that we have to, that OSPAR put out. So this is guidelines for contracting parties to think about how they should monitor for ocean acidification. Those are generally based on best practices of the global community. So all we do is kind of highlight what we feel are recommendations based on the monitoring and assessments that we have to make, but using the kind of the best practices and best guidelines that are already out there through things like GOA-ON and IOC and other places like that. We're also looking at the adequacy of the monitoring in the region. Something we're interested in is using our existing monitoring inventory to kind of say, are there gaps in the monitoring in the region that need to be filled by contracting parties? Are we measuring the right things? If our guidelines say that we need to be measuring 2 of the 4 carbonate parameters, then just having 30% of our inventory is just measuring pH, then that's not necessarily adequate for monitoring in the region. So it's looking through all of those and looking at recommendations for what would be best moving forward. And updating the monitoring inventory itself, so looking at ways to make that easier and more efficient for contracting parties to update and for us to be able to get the information out of that inventory as well. For the actual assessment, we will again be looking at updating our analysis of changing physiochemical parameters. So hopefully there'll be a longer time series now available, given that was a couple of years ago. I think we went up to 2020 in that time series. So we should have a few more years now to evaluate. We will be re-evaluating the older data for quality, so going back to some of those contracting parties to double check on those. But using a similar approach, we hope to provide several lines of evidence to look at both the surface ocean and interior ocean, and using the analysis products and model hindcasts as well. So that gives us a holistic perspective of the change that's occurring in the region. Next slide, please. So what are some of the challenges or moving forward? What do we need? What do we welcome from the community? Really involvement from data generators so that we can get the best quality data and understand issues related to that data. We can always go to the databases that the data is submitted to, but we much rather engage with the community and the people that are generating those data so that we actually understand those issues. So if you know of data sets that we haven't, or you haven't historically engaged with OSPAR or submit to IC's data center, then we would welcome a conversation about what data you have. It is difficult for us to keep track of all the monitoring activities, both this working group and actually the Northeast Atlantic Hub. We have a data asset list as well, which we send out to members. And the working group COCO sends out its inventory for updating, but it does rely on the community to respond to that and to tell us what's going on in terms of activities. And without that information, then actually that doesn't, we can miss data sets that are potentially really valuable, both for demonstrating the value of your data that you're collecting, but also making use of that in these reports to make sure that we have the right information going up to the policymakers and beyond. We're very interested in biological chemical time series that are co-located. This isn't necessarily a physicochemical challenge, but actually when we're trying to think about the impacts, it's really helpful for us if there's biological data that's associated with the chemical time series. So that's always useful to know as well. And getting the data all in one place is a big challenge. Sometimes we get the carbonate chemistry data coming to us, but it doesn't necessarily come with temperature and salinity data. So again, that comes back to really having those contacts for the people that are generating that data. I'm sure on someone's desktop you have all that data together already, because if you're collecting carbonate chemistry, you need that data to understand it. But actually, sometimes when it gets submitted into different data centers, it can get separated out in different ways. And so, again, having a conversation with someone is much easier to find all that information in one place. So we will really welcome engagement and communication in that respect. And next slide, please. Or is that it? That might be it, actually.
Yep.
Yep, that's it. Okay, thank you.
Thank you very much, Helen. Can you see the Q&A box?
Yes. So
there's
question from Jojo. When OSPAR compares trends in acidification in different regions based on pH, we can be misled because the delta pH depends on the initial pH, not change. Is OSPAR also characterizing acidification trends in these regions based on their hydrogen ions? Yes, so we do. I don't think we actually included it in the end in the QSR report, but we do have the hydrogen ion data sets, and actually the aim was to publish a scientific paper alongside the QSR, and we haven't quite managed to get it out yet, but that one had hydrogen ion concentration as opposed to pH or alongside pH. So yeah, valid question, and we do have that. And I think probably for the next assessment, we may well represent both, if not certainly the delta pH change is really useful. But the trend assessment that we do follows kind of Sutton et al. 2023 best practices in terms of de-seasonalizing the data and looking at the trends based on those. So yeah, but yeah, we hopefully we do have that information, and we will hopefully have that in the next report. I think that's a valid point. Thank you.
Thank you very much, Helen. So I guess we can move on then to the next section, which is on the projections, future projections, which will be presented by Yuri Artioli. So Yuri is an expert member of the working group GOA-ON and OSPAR, and he is a co-lead of task 6, as we call it, which is a task on future projections. He co-led the modeling chapter of the OSPAR QSR Ocean Acidification report, and he is a member of the Executive Council of GOA-ON. His research focuses on modeling ocean acidification and climate change and their impact on marine ecosystems. Please, Yuri, the floor is yours.
Thank you, Jos, and good afternoon, good morning, everybody. So just quickly summarize what is the scope of the work that I co-lead together with the bars in OSPAR COCO, and in particular is to provide climate change and ocean acidification projection, as Jos said, to inform all assessment. So while our main work will be to provide the climate change and ocean acidification assessment, and in particular the projection part of it, we aim also to provide information on future projection on climate change and or ocean acidification to all the other OSPAR committees and groups that deliver all the other assessments. And the challenge is obviously to summarize in comprehensive scientific evidence in synthetic and relevant and actionable information. And that kind of picks up the point also that Jim was making about the difference between pH and H+, because we had a conversation for the QSR 2023 about what to include, what were the difference. And at that time, we thought that pH was the indicator that could be best understood by policymaker, but we totally acknowledge the difference and the importance. And so we are, as Helen was saying, we are considering now to see if we can put H+ also side by side. And also the other challenge is that we are delivering this without having resources to run bespoke projection for this assessment. So we have to rely to all models and simulation that both the centers that are represented in the working group, but also all other modeling centers across Europe or international are doing, and then they are happy to share with us. Next slide, please, Jos. And apologies, this I would say next slide quite a lot for these slides. So what we've done for UK for the QSR 2023. So we focused, we used 2 different regional models. That it was Norwicum and Twente for the Arctic, and then Nimo for region 2, 3, and 4. And you can see there the differences in pH between 2050 and the present day in those areas as projected by those models. We decided to focus on 2 different scenarios. At that time, we were still using CMIP 5 style of projection. So we were using RCP scenarios, and we use RCP 4.5, that is kind of the middle of the road scenario, and the high emission scenario, RCP 8.5. Next, please. As Helen said, we focused on 2 indicators, pH and aragonite saturation state. And here you can see the corresponding map for aragonite saturation state. Next. And we focus onto the level. So we provided both surface, but also seafloor, or rather close to the grid model that is as close as possible to the seafloor. And for this one, we, at least for the NEMO-ERSE model, that is the model that we run in PML, we focused only on the shelf area, so the area that is shallower than 200 meters. And we focused mostly at 2050 as temporal horizon. Next, Jos, please. But also we provided some insight also on what could happen after 2050. So we focused on 2050 because we thought that that was the temporal horizon that policymakers were mostly interested. But we thought that we couldn't avoid to present something also beyond 2050, because is where the more dramatic changes will happen if we don't take action now. And so we needed to provide that sense of importance and to the longer term horizon. Next slide. So the key messages from the modeling or the projection chapter was that obviously ocean acidification is projected to occur in all 4 OSPAR regions. That is projected to even accelerate toward the end of this century, and that's why we thought that was really important to show also the longer temporal horizon. That the trends are also especially very variable, and so it is very important to look at this difference and this especially at the regional level. And the part of the seafloor is projected to be corrosive to expose calcareous structure, and that's the translation of basically having a aragonite saturation state below 1. And that's, we already anticipated there that because we only used one model per area, we are absolutely sure that we can't, that's not the future, but is only one of many potential future according to that scenario. And then using multiple regional models of building ensemble would actually be able to quantify and kind of providing an assessment of that uncertainty. Next, please. And that's what we're also basically trying to do towards the intermediate assessment. That is the next assessment in 2029 that Jos was talking. So first of all, expanding the work that it was just focusing on ocean acidification in the Pacific QSR to also other climate change indicator like temperature, salinity, and so on. We will see in a minute which one are we focusing on first. To expand the assessment to all OSPAR area, you will notice that you would have noticed that in the previous slide, I was mentioning that the ocean acidification is happening in all 4 regions. OSPAR has 5, and we haven't mentioned region 5 because our regional model that we are able to use for the past assessment we're covering or was covering very little part of region 5, the wider Atlantic. And as I said earlier, also to address the within scenario uncertainty. So even if we stick with a single scenario, there is obviously ranges of trend for all these indicator. Next slides, please. So we send a service to various OSPAR bodies and committee to try to understand what were their priorities, considering that the information that we will deliver will serve not only the climate change and ocean acidification assessment, but also will need to serve also their purpose. And so we asked what were the scenario that they are mostly interested. And as you can see there, they were mostly interested in SSP 4.5, the middle of the road scenario. There was quite a decent amount also of a group that were interested in understanding alternatives to the business as usual, let's say. So what could happen if we do mitigation of greenhouse gas emission, and what could happen if instead we go back compared to the recent achievement. And so looking at SSP1 scenarios or SSP5 or SSP3 on the other end of the spectrum. And then we ask which variable or which indicator that we're interested. And two that unfortunately, given the context that we're in today, we're not related to ocean acidification, but ocean acidification came second. So we're mostly interested in temperature and oxygen, because obviously they are indicators that strongly affect species and ecosystem. Then there was ocean acidification, and then there was a set of other like marine heat waves, so still temperature, but focusing on extreme event, salinity, nutrient, and so on. And so we will prioritize those that have the largest interest across the groups. And then if time allow, we'll provide the wider assessment, because usually with this model we can have the future trend for most of these variables. Next, please. And because we aim to expand to all OSPAR region, this time we decided that we will start using global models, and obviously the first source of this will be CIMIP6, and that's because that's the only way to provide a comprehensive assessment in all OSPAR region. There are no regional model that covers the entire of the OSPAR region. It allows that quantification of within scenario uncertainty that we're very interested into, because obviously CIMIP provide already an ensemble of model. And what we will do with this CIMIP6 is that when needed and when possible, we will apply some simple bias correction that is just to remove the long-term bias, so that we can actually compare not just the difference between present and future, but also if some of, especially if some of the other OSPAR committee are interested to look at the exceedance of a particular threshold, like could be the omega saturation 1, then we would need to actually try to have the assessment of the present state as close as possible to reality, and that's why we are aiming to do this simple bias correction of the global model. Next. But then we will focus also on regional model, and that's because as I said, they are very regional, they are very spatial variety and diversity in trends. And so we're trying now to collate as many as possible regional climate projection that covers various OSPAR region that we know exist, and then we know that we can get hold of the simulation output, so that we can use them in this assessment. You can see a few listed there from few institutes. You can see PML that obviously are the one that I know best, but there are also simulation from SMHI, from NIVA, from the Marine Institute in Ireland, from Mercator Ocean, from IMR. And the request here, and I think next, yes, please. If you are a modeler, or if in your institute there are modelers that are modeling any part of the OSPAR region, please contact me that I can start talking either to you or to your colleague to see if the product that you are producing is available and would be useful for our assessment. Next. And to conclude, this focus on the regional zooms obviously has challenges. The first one is that because we are opportunistic in the product that we use, we only have a smaller number of scenarios and model. They all cover different part of the OSPAR regions, and you can see there example of 3 different models that has 3 different domains, and the only area of actually overlap or full overlap is the North Sea. And so then how then can we combine all these different models that not only have the different domain coverage, but also have different spatial resolution? They have different setups at the beginning. And so we'll definitely build on the experience of our other multimodal projects, like the OSPAR activity on modeling eutrophication within ICG-OA or Copernicus. But also, again, if you have any experience on doing this and you want to contribute with your suggestion, by all means, just, let's discuss at the end of these talks, or contact me and we can discuss it. And I think with this is over, I guess. Next, Jos. Yes.
Yep. Thank you very much, Yuri, for your presentation. I'm seeing at the moment no questions in the Q&A box, but if anyone still has a question, you can put it in there and we can pick it up at the end of the session, or if we run out of time, we can get in touch with you in writing to get your answer. So the final bit is on indicators of biological impact. So the question why OSPAR is aspiring to have indicators of biological impact, there's many reasons, I guess, but important ones are that these indicators can improve our understanding of the multi-stressor environment that organisms live in. But quite importantly, they are a comprehensible tool to convey science to policymakers. And these policymakers need or want them to communicate with their peers. So policymakers that are not necessarily dealing with the marine environment, but are dealing with shipping or other activities at sea. They're also a good tool to communicate to the wider audience, to just showcase what ocean acidification is doing to the environment. And for those of you that are familiar with the European Union, there is a Marine Strategy Framework Directive, which is a European legislation that does not include climate change and ocean acidification at the moment, but it will be revised, and there might be a requirement for EU countries to build indicators and present them. So in the QSR 2023, the chapter on biological impact contained a brief overview of carbonate chemistry interactions with marine organism physiology to explain the reader what the suite of problems are that organisms might encounter when the carbonate chemistry is changing. And we had a number of case studies on cold water corals, solophilia, on Atlantic cod, on commercial fisheries revenue, and on the shell dissolution of bivalve larvae. But we did not have an indicator of biological impact, like an indicator in the way OSPAR likes to see indicators. And for the next assessment, an indicator of impact is or has been the holy grail that we look for when communicating to policymakers. However, any indicator needs to have geographical coverage at the OSPAR regional level. So that means Greater North Sea or Celtic Sea. So it needs to have a sufficient geographical coverage. It needs to be indicative of the impact that we're looking for, whether it's temperature or ocean acidification. So we need to be able to disentangle the effects that we see in organisms from other impacts, and that's always a very complicated issue. Preferably, it builds on existing monitoring. So setting up new biological or chemical monitoring is very expensive, especially at this very large scale. So we're looking for indicators that use data that are already being generated. And the data that are available would have to be of sufficient length to actually find trends and impact. So basically, this holy grail is still there, but it's not probably not going to be in the 2029 assessment, but it will be hopefully in a later assessment that we can work on something. So we're also looking at alternatives to indicators of biological impact. So one alternative would be to update or brush off the existing case studies, which is not very innovative or very pretty, but it's one thing we can do. We're looking to build or extract from the pelagic habitats assessment that OSPAR produces. So those are assessments on plankton, phytoplankton, zooplankton dynamics and diversity. and they are highly driven by climate change and ocean acidification. So we hope that if we put a different scope or narrative on their results, we might produce something that can be featuring in the climate and ocean acidification assessment. We are actively engaging with projects that are aimed at developing indicators of biological impact. However, this is really a longer timeline because we start the production of the assessment product next year already. And we're also reaching out to the research community to identify suitable case studies. So that would have to be studies that are rounded off. They have a clear narrative and a link to ocean acidification or climate change. And they have to be in the Northeast Atlantic, of course. And we are still in the process of finding these. And we are very happy and eager to learn about more of them. One other thing that we are aiming to do is to produce a guidance for other experts in OSPAR to help them or coach them into incorporating climate change and ocean acidification in their assessment products. So these are assessment products on various ecosystem components, which are listed there, like mammals, birds, seafloor, turtles. But there's also the let's say the non-living part, so underwater noise, litter, eutrophication, chemical pollutions, radioactive substances. There's a load of assessments being made, and we hope to provide a guidance to the authors of these assessments that they get a bit more comfortable with writing about climate change. And the nice thing about that would be that we can summarize whatever they produce in our climate change and ocean acidification assessments to inform policymakers on the general impacts of all these individual stressors. And added benefit of that would be that there's a coherence across the OSPAR quality status report or intermediate assessment, so that we don't have one message in our assessment and a different message that might be a little bit conflicting or just from a different angle in another assessment, so that we speak with one voice, so to speak. So yeah, one important thing ask that I have or we have today is whether you may have what we seek. So we're, like I just said, we're looking to the scientific community to identify suitable cases of studies of impact of ocean acidification, but might also be climate change. And such a case study, it needs to be finished, of course, and available. So at least submitted or something, because otherwise, I mean, we would like to have it featured in our report. So if you can't have it public available yet, then it's not good for either of us. It needs to be conclusive. In other words, it needs to be have a clear message or a narrative in there, and preferably it's situated in the field or in situ. Lab or mesocosm experiments might be of interest, but there it's really important that the manipulation of variables is realistic, right? That it's sort of represents the situations we might see in the field. Another thing is that these case studies would have to represent ocean acidification variable interaction with ecosystem components, so species or habitats, and it needs to be situated in the Northeast Atlantic region, of course. And the researchers that are involved need to want to contribute to our assessment product. So we would get you on board and we would write something together, which would mean that, you know, some input from the researchers is also needed. And then, of course, after the 2029 assessment, we're also very much looking for engagement with projects that aim to develop indicators of impact of ocean acidification or climate change. So if you have any of this, please do not hesitate to get in touch with me or someone else that has been speaking today. So my email address is there at the bottom. And yeah, we're really looking forward to collaborate with the wider scientific community where possible. So that concludes the let's say the general talky bit of me and Yuri and Helen. See, I have one question in the question box. by Zachary Sohu. The question is, can we find low-cost equipment to collect CO2 data? That's something I'm not not really at home in at the cost of. Is that something that Helen or Yuri are at home in?
I did Catherine, are you trying to answer it, or I don't know, there's a comment that's come up that you're, oh no, okay.
No.
I am not a sensor developer, but I am aware that it's not a simple issue. There are people looking at sensor development, with many people looking at sensor development. There was obviously the SAMI PH won the X Prize for sort of low cost and most, I can't remember what the title was, but the most robust and most accurate, I think, or something like that. So that is probably the cheapest single sensor that is available on the market. But again, just having one pH sensor or one, even if we had CO2, there are CO2 sensors, but they vary in price. And yeah, I can't really comment on the development of low cost things. I don't know if Yuri or anyone else actually here is probably a better place to answer it, but there is work going on in that space in terms of trying to bring the cost down and make it more affordable and more replicable, but also recognizing that we need to keep a level of accuracy and quality of those sensors. So yeah.
Thank you, Helen. So we have only a very short time, I see, for the remaining discussion. So we were looking for any points that the audience wants to bring up. You can do it here in the session, but also you can get in touch with us. And I think, like Helen pointed out, that she was looking for data sets, and especially not to send her data sets, but to respond to any calls for data from yeah, that might cross your desk. It's important that we that everyone contributes their data. And the same thing goes for the modeling, right? So if you have regional models that do the biochemical modeling in the Northeast Atlantic, that we can add to our ensemble of models, that would be really amazing. And the same for any case study on biological impact, or any work on indicators for biological impact. We are really open to get in touch with people that have something that they think might be useful or valuable. So we're very, let's say, approachable and flexible in taking up people in our working flow. All right. So given also the time, because we only have 4 minutes left, I'll suggest I stop sharing my screen and thank Helen and Yuri very much for presenting this, and everyone, and give the floor back to Katarina, I think.
Thank you so much. That was very, very interesting. And I think that's going to be of great relevance to the rest of the OA community as well. I hope everybody is going to reach out to you, and you're going to find lots of new collaborators and partners. I would just like to end on a quick comment. We have a session this Friday, actually, on technology development and ocean acidification research. So maybe there will be something in there for the question on low cost equipment. Maybe, or maybe you can find the experts to ask that question up there. All that's left for me to say is thank you so much to the three of you for all the work that you do and continue to do. And please, everybody, get in touch with our colleagues. I would also just like to thank all of the audience members for being here, for following the session, for asking questions. And if there are other OA week sessions that you might be interested in, please I refer you to this QR code to find the full session lineup. This is only day one, so we have another 4 full days with quite a variety of topics. And also, we would encourage you to sign up to become a member to GOA-ON so that you will be among the first to find out about upcoming events and news in ocean acidification research. And with that, all that's left to say is thank you so much and have a great rest of your day. Goodbye.
Thank you all. Bye.
Can't seem to stop recording. Oh, no, there we go.